Now we want to talk about something called law of exponent. This how to work with algebraic quantities containing exponent. That is what we call law of exponent. So there are bunch of laws of exponent. Let's look at each of these individually, and we will work on few examples where we will combine these so many different laws. So the first law of exponent, sometimes we call product rule. The product rule says if you have two quantities, two algebraic quantity with the same base and they are multiplied. The reason we call them product rule is there are two quantities with the same base and there is a product of them. That means the two quantities with the same base are multiplied. Here, if you have an exponential thing, if we have x to the 5, we call x to the base and we call the number on the top, this is called the exponent. Basically, in order to understand the law of exponent, this is what we need to understand. X to the 5 basically means x is multiplied 5 times. X to the 5 is x times x times x times x and times x. If a quantity is multiplied 5 times with itself, we get the quantity raised to the 5. So basically what does this mean is a is multiplied m times and a is multiplied n times. This total will be equal to a multiplied raised to the m plus n. Well, I will show you this example how it works. Let's say x to the 5 we already know. Now let's say x to the third is x times x times x. X is multiplied 3 times. If we want to multiply x to the 5 with x to the third, what happens is x to the 5 is x times x times x times x times x 5 times, and x to the third is x times x times x. We are multiplying this quantity with this quantity. Now how many x we have? 1, 2, 3, 4, 5, 6, 7, 8. So this is nothing more than x to the 8. So look at this now, x to the m times x to the n, x to the m times x to the n is x to the m plus n. So where m is 5, n is 3, x to the m plus n. 5 plus 3 is 8. That is what we call the product rule of exponent. What the product rule is saying is, if you want to multiply two quantities with the same base, add their exponent. Adding the exponent is equivalent to multiplying two quantities with the same base. Now the next rule is called quotient rule. What this rule is this: suppose you have a to the m divided by a to the n. Two quantities with the same base is dividing each other. Then this is equal to, according to quotient rule, this is equal to take the base and subtract the exponent. Subtract the exponent of the denominator from that of the numerator. So a raised to the m minus n. In order to understand this, see, x to the 5 is x times x times x times x 5 times. If we want to do x to the 5 divided by x to the 3, that means x times x times x times x times x 5 times divided by x times x times x 3 times. this x and x cancels out, x and x cancels out, x and x cancels out, so we should be getting x to the 2. And this rule is exactly saying the same. What this rule is saying is, if you want to do x to the 5 divided by x to the third, do this is equal to x to the 5 minus 3, which is x to the 2. This is called quotient rule. The zero exponent rule says this: any number raised to the 0 is 1. Any number raised to the 0 means there is no exponent, so it should be 1. Now, the negative exponent rule says this. We write like this: a negative n, a raised to negative n, negative number in the exponent. This means nothing more than 1 over a raised to the n. Negative exponent means reciprocal of the positive exponent. Reciprocal of the positive exponent. Well, if we have this, okay, if we have 1 over a to the negative n, we can write a to the positive n. So basically, see, the negative exponent means reciprocal of the positive exponent. Reciprocal of 1 over a to the negative n, a to the n is a to the n. Well, the next rule is called powers to power rule. What this rule says is this: if you have a power m and another power n like this, a raised to the m, and the entire quantity is raised to the nth power. Basically, what this means is multiply a m times, a times, a times, a times, m times, and that block, the m factors are multiplied again n times. So what this gives is a m times n. So if you have powers of power, the powers of power multiplies together, m times m, n. A m raised to the n means a m times n. Okay, the next rule is called product to. The next rule is called product to power rules. What does this mean is, suppose you have a product, let's say a times b, the two quantities are multiplied, a times b, the two quantities are multiplied, and there is a single exponent m. This is nothing more than a to the m times b to the m. If there is a single exponent of a product, the exponent distributes into each factor. That's what the product to power rule means. Well, the quotient to power rule is similar to product to power rule. If we have a fraction a over b and a single exponent, naturally the exponent is distributed with a and b both, a to the m divided by b to the m. Okay, after looking at this rule, we want to simplify now. We want to use law of exponent to simplify algebraic expressions. We want to use law of exponent to simplify algebraic expression. Well, simplifying in this situation means have no parenthesis, no powers to power. So we don't want to see power to the power, no powers to power. Each base should come only once, so one base should appear only once, no more than once. There should be no negative or 0 exponent. We don't want to see a negative exponent, or we don't want to see 0 in the exponent. Look at this expression. If you look at this expression, it is not simplified, because see, the first thing says 2 raised to the negative 1. So this negative 1 is already a negative exponent. We don't want that. See, you have bunch of parentheses. We have bunch of parentheses. Here is a parenthesis, here is another parenthesis, here is another parenthesis, here is another parenthesis. We don't want that. Moreover, see, there is an exponent to the quantity inside parenthesis that gives us powers to power. There are powers, like in the denominator, y to the negative 6 is a power of y, that negative 6 is a power of y, and because of that square outside, that is again power to power. So we don't want powers to power. Well, let's see how we can simplify this. This is not simplified because it has negative exponent, it has parentheses, in fact it has 0 exponent also, and this is why it is not simplified. So in order to simplify, now we are trying to simplify this. In order to simplify, I'll write here, so I'll have a little bit of space. In order to simplify this, first of all, well, we need to keep working with our law of exponent. If you look in the first parenthesis, there are 3 things multiplied. One is 2 raised to the negative 1, another is x raised to the negative 3, another is y raised to the minus 1. 3 quantity multiplied, and there is a single power. That means this quantity right now, this quantity, this quantity right now is exactly of this type, meaning that 2 or more quantities are multiplied and there is a single exponent. According to this rule, the single exponent distributes to each of the factor, meaning that the single exponent distributes to each of the factor, meaning that this negative 2, we will get 2 raised to the negative 1 raised to the negative 2. This exponent is gone to the first quantity, and x raised to the negative 3 and raised to negative 2, and y raised to the negative 1 and raised to negative 2. This negative 2 is distributed for each of the 3 quantities. Similarly, the next negative 2 will be distributed to each of these 3 quantities, and the 0 will be distributed to each of these 3 quantities, and similarly the 2 in the denominator, the exponent 2 in the denominator will distribute to each of the 3 quantities inside the parenthesis. Well, before I write next of the things, let me simplify how much it will be. So we can apply the same rule for simplifying the rest. So now the first one is 2 raised to the minus 1 raised to the minus 2. We have power negative 1, again another power negative 2. Recall the property, powers to power, the 2 powers multiplies, meaning that we will get 2 minus 1 times 2, minus 1 times minus 2 is 2, positive 2, minus 1 times minus 2 is positive 2. Similarly, here is x, minus 3 multiplies with minus 2, minus 3 times minus 2 is positive 6. Similarly, y, minus 1 times minus 2 is positive 2. So basically the first quantity simplifies to this much. Using the same rule, the next quantity now, because this minus 2 goes to the exponent of each, we will get 2 raised to the minus 2, x raised to the minus 6 times minus 2. Minus 6 times minus 2 gives us positive 12. And similarly, y raised to the 4 times minus 2. 4 times minus 2, negative 8. The last thing is so easy, because if we see a 0 exponent to any quantity, that is nothing more than 1. So I don't want to even do anything in here, because this is nothing more than 1. So that is our numerator. Now let's look in the denominator. Let's look in the denominator. The same rule, this exponent 2 distributes to everything. So we will get 2 raised to the 2. This exponent 2 goes to 2. X raised to the negative 4 times 2 is negative 8. Y raised to the negative 6 times 2 is negative 12. By the way, if you see common thing in the numerator and denominator, we can cancel. So here I see 2 raised to the 2. Here is also 2 raised to the 2. We can cancel those two things. Now another thing we don't, now you have so many, see, you have only 2 variables, okay, x and y. There are only 2 bases, but they are at so many places. Here is 1, here is 1, and here is 1. Y is here is 1, here is 1, and here is 1. By the way, we can combine this 1, the number, and 2 to the negative 2 is also a number. 1 times 2 to the negative 2 is 2 to the negative 2. So first of all, I'll write the number. So 2 to the negative 2 remains the same. No change in the number. Now recall, simplifying means writing a single base. For one variable, we want to see a base at only one place, not several times. For example, this x, which is a base, is appearing here and here and here as well. We don't want that. So we want to have a single x. We will want to collect all the base. See, this x to the 6th is multiplying with x to the 12. Two quantities with the same base multiplying means their exponents should be added. So 6 will be added to 12. In the numerator there is 6 exponent, another exponent is 12, they will be added. And again, with the same base in the denominator, there is x to the negative 8. So x to the negative 8 is dividing whatever the quantity containing x in the numerator. Recall that dividing two quantities with the same base means subtracting the exponent. That means I want to subtract minus 8. Subtract minus 8, minus 8. 6 plus 2, the exponent in the numerator added, and the exponent in the denominator is subtracted from that of the numerator. Now let's do the same thing with y. So y now, y raised to the, here is 2 minus 8 and minus of minus 12. 2 minus 8 minus of minus 12. This quantity is divided. Dividing is already done. Okay, dividing is already done, sorry. Now, so this is equal to 2 raised to the negative 2, x raised to the, how much, 6 and 12 is 18, minus and minus plus 8, 18 plus 8 is 26. And y, 2 minus 8 plus 12. minus and minus plus. So 2 and 12 is 14, 14 minus 8 is 6. Everything looks fine, negative 8 to negative 8, positive 12. So that sounds okay. Everything looks okay except for we still have our negative exponent here. This negative 2 is our negative exponent and we don't want that. We don't want that means we want to make a positive exponent. So x to the 26 is positive exponent, that's fine. Y to the 6 is positive exponent, that's fine. Recall that negative exponent means reciprocal of the positive exponent. That means I can write this down like this, 2 raised to the 2. If I write down that in the denominator, I can write down with the positive exponent. By the way, 2 raised to the 2 is 4. So this is x to the 26, y to the 6 divided by 4. Okay. So this is the simplified form. We do not have any negative exponent. One base is appearing only once. There is no parenthesis. So everything that is needed to be done to simplify it is done. Well, when we have a fractional exponent and sometimes radical exponent, well, fractional exponent means something like this, x to the 2/3, x to the 3/4. It is a fractional exponent. Fractional exponent can be written as radical exponent also. What do I mean by radical exponent? We will simplify it in a second, but let me show you what do we mean by radical exponent. If we have this x to the 2/3 means nothing more than this. We write like this. We write this symbol, the denominator of the fraction here and the numerator of the fraction here. This is all the fractional exponent means. Well, if there is a special case, if the fraction is 1/2, x to the 1/2, special case 1/2, then this should be written like this. We should write a 2 here, but notationally if we don't write a 2, it is already understood there is a 2. So if there is a fractional exponent and 2 is in the denominator, no need to write on the cap of that radical sign. If the denominator is anything else, we need to write. So this is the meaning of rational exponent, and rational exponent or the fractional exponent can be written as a radical sign. Radical sign is this sign is called radical sign. So we have it. Now the rule of simplifying an expression containing a rational or fractional exponent or radical exponent remains the same. All the rules, whatever we discussed till now, will apply. So in order to simplify this is what we will do. Well, this 3 means 3 raised to the 1, this 3 means 3 raised to the 1. There is no exponent, so 3 raised to the 1 remains 3 raised to the 1, x raised to the 2/3, 3 raised to the 1 and x raised to the 3/4. This 3 and 3 same base, so we can collect the base. Since they are multiplied, the exponent will add 1 plus 1 is 2. 3 times 3 is 3 squared. 3 times 3 is 9. 3 squared is 9. And now here is a x, here is a x. Their exponent should be added 2/3 plus 3/4. The exponent adds with exponent. Well, this 9 is 9, 3 to the square is 9. If we add 2/3 with 3/4, well, when we add, we need to take the least common denominator. Least common denominator is 12. So 12 means this is 4. You will get a 4 times 2 is 8, and 3 times 3 is 9. So basically, simplified version will be 9x raised to the 17. 9 plus 8 is 17 divided by 12. Okay, so this is how we simplify. This is how we simplify algebraic expression containing exponents and radical signs.